Relative to a fixed origin O, the point A has position vector 2, minus 1, 5. The point B has position vector 5, 2, 10. And the point D has position vector minus 1, 1, and 4. The line L passes through the points A and B. Find the vector AB. Find a vector equation for the line L. Show that the size of the angle BAD is 109 degrees to the nearest degree. The point ABD, together with the point C, are the vertices of a parallelogram, where ABCD, where AB vector equals the vector DC. Find the position vector of C. Find the area of the parallelogram ABCD, given your answer to 3 significant figures. And find the shortest distance from the point D to the line L, giving your answer to 3 significant figures. So let's have a look at this then. Here's the question in summary form here. Because it's such a long question, I'll try and put some of the answers in the actual question itself. So the first thing was to find AB, so I'll put it here. So the vector A to B then is just B minus A, isn't it? So 5 minus 2 is 3. 2 minus minus is plus, 3J. 2 minus minus 1 is 2 plus 1. 10 minus 5 is 5K. So there's AB. So just underline that. Find the vector equation of L. So I'll put that here. R is equal to. L is the point line passing through A and B. So we'll start off at A then. 2I minus J plus 5K. So there's A plus lambda, scalar multiple of B minus A, isn't it? Of AB rather. 3I plus 3J plus 5K. So that's that one. That's part B. Show that the angle BAD is 109 degrees. So I need a little picture here. So I'm going to draw a little triangle here, like so. This is B, this would be A, and this would be D, and we want to show this angle is 109. We'll label it theta. Now, what have we got here then? Well, we've got the vector AB, haven't we? We've already got that here. We need the vector AD. So let's just put that here, AD then, as a vector. D minus A. So minus 1 minus 2 is minus 3. 1 minus minus 1 is plus 2. And 4 minus 5 is minus 1 lot of K. So there's AD. A to D, this take that is minus 3, this take that is plus 2, this take that is minus 1, that's fine. So these lengths, AB length then, 9 is 18 and 25 is 43. So that length would be root 43. This length here, AD, 9, 1 is 10 and 4 is 14, so that's root 14. Just by looking at the modulus of these two vectors AB and AD. So I'll just underline that there as well. So we've drawn it in a triangle here then. So we do the product. So this is now part C. So here AB is a vector. Dot product with AD will equal the modulus of AB, which we said was root 43, times the modulus of AD, root 14, times the cosine of the angle in between them. So what's the dot product of these two vectors? Here they are here. So 3 times minus 3 is minus 9. 3 times 2 is 6. And 5 times minus 1 is minus 5. And that equals minus 8. 9 minus 9 plus 1 is minus 8. So that tells us what cosine theta is then. Is equal to, will be minus 8 over root 43 times root 14. Now it's a negative cosine. If you think about the cosines from 0 to 360, our angle between two lines will be one of these two. Because it's negative, it's in the second quadrant. So if we do shift cos of the acute angle, so shift cos of 8 divided by bracket square root 43 times the square root of 14 close the bracket, equals, we get 70.1 degrees. But as we said, that's the associated acute angle here. So it's 180 minus 70.1, which is 109. 180 minus 70.1. Oh, sorry, it's 71 degrees. It's 71 degrees to the nearest degree. So let me write that correctly now. So theta then is equal to 180 minus 71, wasn't it? Which is 109 degrees, which is what we wanted. So that was the associated acute angle. Cosine was negative. We did shift cos of this. We got 71. This was 71. So our angle was round to here. 180 back 71, which is 109 degrees. So there's the angle theta then in our picture here. So let's just put it in here. That's now 109 degrees. Okay, so that's part C done then. Now D, find OC. Okay, so we've got a parallelogram. ABCD forms a parallelogram where AB equals DC, AB equals D2C. So there would be C, wouldn't it? So, okay, so AB equals DC. So what is AB? 335. AB is equal to 3I plus 3J plus 5K. Okay, now that's equal to DC. Now C we can label as X, Y, Z in vector form, of course. D has, we've shown what D was before. It's minus 1, 1 and 4. I'll just write it briefly here. So what have we got then for CD? We've got X minus 1 is X plus 1. I plus Y minus 1J plus Z minus 4K. So there's our vector then, and that was D to C is equal to AB. So that tells us what X is. X will equal 2. X will equal 2 to get 3. Y will equal 4. Because 4 minus 1 gives 3. And Z will equal 9. Because 9 minus 4 gives 5. So OC then, so the vector OC is equal to 2I plus 4J plus 9K. So that's part D done. Now E, find the area ABCD. Here's our picture. If I drop a triangle out here, you can see parallelogram. It's just the area of this triangle, and they're the same, is a half BC sine of the angle included. And we've just got two exactly the same triangles here, so we can drop the half. So E, area, instead of half BC sine A, it would just be BC sine A, so it's root 43 times root 14 times sine of the included angle 109 degrees. So let's tap that in. We want it to 3 significant figures. Square root 43 times the square root of 14 times the sine of 109. And I'm still inside the square root, so I need to get outside of that. I'm still inside the square root all the way through, actually. So root 43 times root 14 outside the square root times sine of 109 degrees, close bracket, equals 23.2, isn't it? 23.2 units squared, because it's an area, and that was to 3 significant figures. Now the last part then, part F, find the shortest distance. So if we look at this triangle, this parallelogram we've drawn, find the shortest distance. If I just carry that line on, I know it's badly highlighted here, but you can see that's a right angle there now for the shortest distance from the line. And basically we've got a right angle triangle. Longest side is root 14, and this angle here is 71. So the length here, L, shortest distance, will be root 14 sine of 71. So let's make room for that then. F, answer. The longest side of that triangle was root 14, and it was the sine of the angle 71 degrees. So just get that then. So it's root 14 times the sine of 71 degrees equals 3.54 to 3 significant figures. 3.54 units, because it's a length, and that was to 3 significant figures.